Consider the following graph. So when I want to make the adjacency matrix, the most natural way to do it would be to label these alphabetically. However, you don't have to do it alphabetically. It just makes the most sense. It's always a good idea to label the rows and columns on the matrix, as I've done, but it's not mandatory. Let's look at the row for V, row 1. There are edges from V to W and Y. So I will put a 1 to W and a 1 to Y. And then we look at the second row for W. There are edges from W to V, W, and Y, and X. So there will be 1s for V, W, Y, and X. Looking at row X, there is an edge from X to W, so there will only be a 1 in the W column. And then looking at the row for Y, there are edges to V and W, so we put a 1 in those columns. So this is again called the adjacency matrix. If there are multiple edges, then you would put a 2 there, or a 3, or however many copies of that edge appear. However, the one sort of inconsistency is that loop from W to W, we put a 1 because there was only one loop. Earlier, I said that a loop counts as degree 2. So W has degree 5, even though that row only has 4 values. So we can't get degree by just looking at rows because of loops. But anyways, just to repeat myself, if the graph had multiple edges like this, then we would put a 2 from V to W because there are 2 of those. And then looking at W, there were 2 going to V. But we count a loop as a 1 still because it is only one edge, even though it has both ends at W. So what we're going to do this time is not make an adjacency matrix, but rather, if someone gives you the matrix, find the graph. Okay, so that's an adjacency matrix. I'll start by labeling it with A, B, C, D, E. And let's draw that figure. I don't know the best way of drawing it without giving it a first try. So I'll just draw them in a ring. A is connected to A, so a loop, C, D, and E. B, the second row, is connected to B and E. C is connected to A and D. D is connected to A, C, and E. And E is connected to A, B, D, and itself. So this figure that we've drawn here is a graph with the adjacency matrix given on the left.